Now imagine you as a doctor responsible for analyzing electrocardiogram signals from patients at the hospital that you lives, and then you have one task to do through all your day work. And the thing is, try to diagnose possible heart anomalies from each patient at the hospital that you works. However, there's a thing, if you don't have many exams to process at all your day work, let's be honest, probably this won't be a problem for you. However, you as a specialized doctor probably will treat people not only the city that you lives, but all the entire surrounding region too. After all, you're a cardiologist, you're a specialized doctor on this topic. You're going to get some high demand on that. And then you have to organize all those ECG analysis signals from each patient somehow. Trying to solve this problem, I created a dashboard, specifically a ECG Analysis Dashboard, which is going to get some organized application to make the doctor's life easier and consequently the patient's care too. Hi everyone, watch me. My name is Guilherme Gabriel, and today I would like to share with you guys my ECG Analysis Dashboard. So in this video I would like to show to you guys how this dashboard works, and if you really want to see more about how it works or how I've done the analysis of the digital processing of the ECGs, and you can also check it out my official repo of this application over here, Guilherme Gabriel /ECG Dashboard Analysis. Here you're going to see some topics more about the digital processing of the ECG signal and also the dashboard's architecture. Talk more about how I use Streamlit to build all this application in Python and how I applied it to make this dashboard visualizable and beautiful to the eyes of the user. Okay, everything starts in the terminal, specifically in my case the VS Code terminal, where we'll activate the virtual environment and run the application this way. Getting source virtual environment being activated to activate the virtual environment, and then run the application using the Streamlit library. Okay, we're going to get the local URL, and then we're going to be redirected to the initial app section. So this is an app section and serves only as an entry point of the dashboard, and here you're going to see more about the project, about me and my motivation to build this application, and some ways to connect with me. So as I said before, this is only the entry point of the application, and because of that, the main thing that you need to get some attention and pay attention is more about at the left of the application, at the sidebar. Here we have some names that you're probably going to click to access the dashboard. Go to the Sign In tab right here, click up and go to the Doctor's Access. Here we'll go into Sign In tab, and here you will have two options: login using already registered account here, or a newly registered account, going and click up here. Here we need to get some information about you as a doctor, your personal data, your contact professional data, which involves some documents about your medic proficiencies, and of course security involving your password. So after that, after you get registered, you go back to the Sign In tab and put the CPF, which is going to be my identical document to access the dashboard in this application. In my case, I'm going to put the admin account to run and then to enter the system. Okay, this is our home page, which will give us a brief introduction to the dashboard, and the most important thing will be here on the left, as I said again, on the sidebar, which is going to have two options: the register the ECG signal, and of course view and visualize the ECGs. These two is going to be our main buttons to the application. First thing first, we're going to register the new ECG signal, and this is the page where the doctor will register a new ECG signal from the patient to be analyzed. you need to upload the raw ECG signal, drag and dropping file over here, browsing files, and then get the signal. In my case, I choose to drag the files as the MATLAB format because this product is more about academic than professionalized. After that, we have to put some information about the patients, like the full name, age, sex, and some exam information. And then you click up and save ECG and patient data to save this form associated to this signal. And then you can go back to home and view and analyze the ECGs that you already registered. So here we will select ECG signal to be analyzed, and below we can see how it impacts to the ECG signal. You can select it by the patient over here, which is going to be the ECG that you as a doctor will analyze. The digital filter chosen for the filter, as you guys can see by these two parameters, is the bandpass filter. And below we can see how it impacts the ECG signal. Talking more about the time domain, the raw signal is showing in blue and the filtered ECG is showing in orange. We can immediately see from the frequency spectrum over here in the frequency domain. We can immediately see from the frequency spectrum that our desired frequencies are between 0.5 and approximately 0 and 24-25 Hertz. We can then change the cutoff frequencies of our bandpass filter here in the sidebar to attenuate the noise and leave only the desired frequencies, which is going to be this interval between the 0 and 24-25 Hz. Let's set up these parameters. Okay, 0.5 will be enough, and we can adjust the high cutoff frequencies to 24-25. Okay, and below is a simple statistical analysis to detect the peaks of energy based on the energy variation with the anomaly detection. So here there are positive and negative limits, and the logic that I used to detect these energy peaks was as follows. If a very high energy variation occurs at a given point like this in the signal analysis, it means that specific point it be considered as an anomaly event. And in this sense, when one of these peaks exceeds the limits, like the positive limit or positive threshold, or even the negative threshold, it will be counted as an anomalous event to be noted by the doctor. Note one thing after all of the building of this digital signal analysis. Note that if I haven't implemented the filter, our analysis of anomalies in the patient's ECG signal may be completely compromised. So pay attention and take care modifying these two hyperparameters, because this will be directly associated to the building of our bandpass filter, and consequently the way that we can get the interesting gap to get some considerate frequencies to be used in our analysis. And speaking more about ECG analysis statistics, to be honest, I'm aware that statistical analysis to study possible anomalies are more complex and delve deeper into statistics. This was just a way for me to try to find possible anomalies events and to somehow facilitate the doctor's analysis of electrocardiogram signal.